particle is moving in a straight line has a velocity of v meters per second such that t seconds after leaving a fixed point, v is equal to 4t squared minus 8t plus 3. Find the acceleration when t is 3. So for acceleration we need to differentiate. So that's going to give me 8t, take away 8. And therefore a of 3 is going to be 8 times 3. Take away 8, which is 16 meters per second squared. Find the values of t for which the particle is momentarily at rest. So rest means velocity is 0. So I've got 4t squared minus 8t plus 3 is equal to 0. Let's have a go at factorising that. It may factorise. If not, we'll just go to the formula. So 2t and 2t, 3 and 1, and make them both minuses, and that works fine. So we've got t is equal to 3 over 2, or t is equal to a half. And then we want to find the total distance the particle has travelled when t is equal to 1.5. So, well, we know that s of 0, the distance when 0 is 0. That's just by definition that we start measuring time from when it leaves a fixed point. So we need an expression for s, or I often use x for that one, but I'll use s here. And from the velocity we need to integrate. So this is the velocity expression just here. So it's going to be 4t cubed over 3, take away 8t squared over 2 plus 3t plus a constant, and 0 is going to be 0, take away 0 plus c means that c is equal to 0, and that's obviously using this fact. And so s is going to be 4t cubed over 3, take away 8t squared over 2 plus 3t. And we'll need to know at both of the times when it stops where it is. So s of 0.5 and s of 1.5 we want. So we've just simply got to evaluate those. So we have 4 times 0.5 cubed over 3, take away 8 times 0.5 squared, and that's over 2. I could of course simplified before I did this, but it doesn't matter too much. Plus 3 times 0.5. That gives me 2/3. Or you might get a decimal answer, 0.666 and so on. And then we need s of 1.5, so I'm just going to go back and edit here. So change that to a 1.5 there. Just keep clicking back through. Change that to a 1.5. Clicking back through. Change that to a 1.5. And that's 0. So back at the beginning. So what must have happened is it's gone from O, its start point, it's gone to here when t is a half, and that distance is 2/3, and then it must have come back 2/3. So the distance travelled, so that's not really as is it. So distance is going to be 4/3 of a metre.